All right. Okay. So module 4, yeah. So module 4, we start with ACL and probably today 2 chapters and 4 configuration as well. Yeah. All right. So ACL concept. Module objective explain how ACL are used as part of network security policy. Yeah. The purpose of ACL is very important. Okay. In order we need to do filtering. So we need to know how to do a setting using ACL. Yeah. Purpose of ACL explaining how ACL filter traffic, wildcard, how to use that in ACL, guideline for ACL creation, and there are a couple of types in ACL in IPv4. Yeah. Okay. So purpose of ACL, basically, what is ACL? Okay. Oh, can we change this one? Yeah. All right. And doesn't matter. I would like to hide this, but all right, that's better. Okay, what is the ACL actually? Yeah. So an ACL is a series of iOS commands, yeah, that are used to filter packet based on information found in the packet header. Okay. By default, router does not have any ACL configured. When an ACL is applied to an interface, the router performs the additional task of evaluating all network packets as they pass through the interface to determine if the packet can be forwarded. All right. So an ACL uses a sequential list of permit or deny statement known as access control entries or ACE. Okay. ACL access control list. Yeah. ACE are commonly called ACL statement as well. Yeah. So when traffic passes through an interface configured with an ACL, the router compares the information within the packet against each ACE, yeah, each of the entries in sequential order. So means from top to bottom, yeah. So it's not from bottom to top, yeah. Okay, to determine if the packet matches one of the ACEs, yeah, entries, this process is called packet filtering. So this is how they do filtering. Okay. Several tasks performed by routers require the use of ACL to identify traffic. First, okay, we can limit network traffic to increase network perform, okay, by this ACL, and provide traffic flow control, provide a basic level of security for network access, filter traffic based on traffic types, screen hosts to permit or deny access to network services. Okay, we can do that as well. Okay, we allow a couple of services we can do protected. Okay, and provide priority to certain classes to network traffic. Okay, classes mean some certain classes, especially on the IP addresses. Okay, because we use a wildcard, also subnet mask. Okay, we can control the traffic flow. Okay, so that's the benefit of this ACL. Yeah. Okay, packet filtering. Okay, packet filtering control access to a network by analyzing the incoming and or outgoing packet and forwarding them or discard, okay, them based on given criteria. So based on certain criteria, okay, they will do analyzing, okay, or filtering, okay, whether for incoming or outgoing. All right. So packet filtering can occur at level 3 and 4. Okay, we need to decide. Okay, level 3 or level 4. So Cisco routers support 2 types of ACLs, standard ACL and also extended. What are standard ACL? ACL only filter at level 3 using IPv4 address only. Okay. But for extended ACL filter at level 3 using the source and or destination IPv4 address. They can also filter at layer 4 using certain protocol, TCP or UDP, yeah, and also some optional protocol type information for finer control, more on specific, which type of application we want to block. Okay, we have TCP, UDP, and we have FTP, yeah, and then HTTPS. Okay, that kind of protocol. Yeah, all right. Okay, ACL operations. ACL define the set of rules. Okay, so ACL actually define the set of rules that give added control. Okay, for packet that enter inbound interfaces, packet that relay through the router, and packet that exit outbound interfaces of the router. So mean inbound or outbound or incoming or outgoing packet can be filtered. Yeah. Okay, ACL can be configured to apply to inbound traffic and also for outbound traffic. Yeah, incoming or outgoing. ACL do not act, yeah, on packet that originate from the router itself. Okay, so an inbound ACL filter packets, yeah, and inbound ACL, yeah, in inbound ACL filter packet before they are routed to outbound interface. Okay, so inbound ACL so filter packet before they are routed to outbound interface, and inbound ACL is efficient because it saves the overhead of routing lookups if the packet is discarded. Yeah. And outbound ACL, yeah, outbound ACL filters, yeah, packet after being routed, yeah, regardless of the inbound interface. Okay, there's some criteria you need to take notes. Yeah. Okay. This one inbound, this one outbound. Incoming, outgoing from this router. Okay, that's mean by inbound and also outbound or incoming or outgoing. All right. So ACL operation. When an ACL is applied, yeah, to an interface, mean that ACL will apply on interface. Okay. It follow a specific operating procedure. Here are the operational steps used when traffic has entered a router interface with an inbound standard IPv4 ACL configured. Yeah, first the router extract the source IP address from the packet header. Yeah, and the router starts at the top of ACL. Okay, from top, and compares the source IPv4 address to each ACL statement or ACE, ACS control entries in a sequential order. All right. Third, when a match is made, the router carry out the instruction. Okay. Either permit or deny. Either permitting or denying the packet. And the remaining ACEs in the ACL, if any, are not analyzed. Okay. All right. So if the IPv4 address does not match any ACEs, yeah, in the ACL list, the packet is discarded because there is an implicit deny ACE automatically applied to all ACL. Yeah. Okay. The last ACE statement, okay, of an ACL is always an implicit deny that blocks all traffics. Okay. it is hidden and not displayed in the configuration by default. So it will block. Okay, the last statement of NACL is always implicit deny that block all traffics. Okay, but not in the ACL, but by default. By default, it will block all the traffics. Okay. So an ACL must have at least one permit statement, otherwise all traffic will be denied due to this statement or due to the implicit deny ACE statement or ACL statement. Yeah, all right. Okay, so this one you can do a bit later. Okay, wildcard. In order to implement this ACL, you need to know the wildcard. Yeah, wildcard mask. Okay, a wildcard mask is similar to a subnet. Yeah, in that it uses aiding process to identify which bits in an IPv4 address to match. Yeah, unlike a subnet mask. Okay, a bit different. Yeah, wildcard. Yeah, in which binary 1 is equal to a match, and binary 0 is not a match in a wildcard mask. So the reverse is true. Yeah. So an IPv4 ACE use 32-bit wildcard mask to determine which bit of the address to examine, yeah, for a match. Wildcard mask use the following rules, yeah, to match binary 1 and zeros. Yeah. Wildcard mask bit 0 mean match the corresponding bit value in the address. While wildcard mask bit 1 means ignore the corresponding bit value in the address. Okay. So this one, wildcard mask 00 means, okay, last octet, the last, this one, yeah, the last one here. So we convert to binary. So this one means match all octets. So in here means all octet, yeah. And then if you put 000, all 0 means match all octet. This one, okay, the last octet in here, 63, and then what happened? They match the first 3 octet. Yeah, the first 3 octet, and then match the 2 leftmost bit of the last octet. This one, and ignore the last 6 bit. Okay, ignore the last 6 bit. Okay, and similar to this case, we have 0.0.0.15. Okay, when you convert to the last octet in binary, we will have this, yeah, for 15. And then here, match the first 3 octet, yeah, and then match the 4 leftmost bit of the last octet, yeah, this one. And then ignore the 4 bit of the last octet, which is all 1 here. All right. And next example, for wildcard 0.0.0.248, and then you convert the last octet, it will become this, yeah. And then means match the first 3 octet here, because this one all zeros. And ignore the 6 leftmost bit of the last octet, 6 left here, because these all ones. Okay, and then match for the last 2. Yeah, bits. Okay, and next example, 0.0.0.255, yeah, right? Okay, in here, if you convert the last octet, it will give you 111, all ones in the last octet. So match the first 3 octet, of course, this one, and ignore the last octet. because it is all ones. Okay, all right, this one for wildcard. Wildcard mask types. Okay, wildcard to match a host. Assume ACL 10, yeah? Needs, this one ACL 10 is a number. Needs or label, yeah? Needs an ACE that only permit the host with IPv4 address 192.168.1.1. Okay, recall that. The concept fundamental. 0 mean equal to match and 1 equal to ignores. Yeah, we ignore that if 1. Okay, to match a specific host IPv4 address, a wildcard must consist of all zeros. Okay, is required. Okay, so when the AC is processed, the wildcard mask will permit only this. Okay, address. Yeah. So as the result, ACE in ACL 10, okay, will be access list 10 permit 192.168.1.1 and then all 0. Okay. All right. So this IPv4, we're converting all here. And then the wildcard is 000. And then, so the permitted IP address, so all here. Okay. We do each of these. So specific IP. So we do on this IP. Okay. All right. Okay. So this is how we want to filter to specific IP. Yeah. Specific IP address. Okay. We need to use wildcard 000. Yeah. Okay. Wildcard must to match an IPv4 subnet. Okay. Certain segment. Okay. CL10 label. Yeah. And then needs an ACE that permit all hosts within this network 192.168.1.0/24. The exact wildcard mask is 00.0.255. Yeah, stipulates that the very first 3 octet must match exactly, but the 4th octet does not. Okay, according to this. Yeah. Okay. So when processed, the wildcard mask 0.0.0.255 permit all hosts in this /24 network. Yeah. So the resulting AC in ACL 10 will be access list 10 permit 192.168.1.0 is a network IP and the wildcard. Okay. 0.0.0.255. Okay, means here the last octet here. Okay, this is wildcard. So means all these segment, yeah, will permit, yeah, to access or allow. Okay. All right. And then wildcard mask to match an IPv4 address range. 1 second, yeah, address range. Address range. So now range of address. So ACL 10, for example, needs an AC that permit all hosts in this 192.168.16.0. Yeah. And then from that range until this range. Oh, all this 116, yeah, 17, 31. Okay, all networks. Okay, from 16, 17 until 31. All right, so when processed, the wildcard mask is 0.015.255. So permit all hosts in this range of network. This one. Okay, 16 until 31. 16 here until 31. Okay. All right. This one we have learned already in subnetting in class netcom, how to do subnetting and do select on this. So this is the wildcard. So the resulting ACE in ACL 10 will be access list 10 permit. Okay, this is the network address and this is the wildcard. Okay, this wildcard reflect to this network address. Okay, all right. So just please recall this, how to do a subnetting and this, yeah. So how many bits we are using for this. Okay, this one for wildcard. Okay, all right. And then wildcard mask calculation. Calculating wildcard mask can be challenging. One shortcut method is to subtract the subnet mask from subnet mask 255, 255, 255, 255. Okay, assume you want ACL 10 to permit all user in this network. Okay, /24. So to calculate the wildcard mask, subtract the subnet mask. Okay, so subnet mask is here, /24, and then from here. This will produce wildcard mask 00.0.255. So the access list will be access list 10 permit this 192.168.3.0.0.0.255. Okay, this one regarding wildcard mask. Later we'll go for each of these access list, how to create access list. Okay, so this one regarding wildcard. Okay, wildcard mask. Assume you wanted, another example. Assume you wanted an ACL in, ACE in ACL 10. So we have another example to permit network access for 14 users in this subnetting. In this subnet. Okay, /28. Okay, please recall that. And then subtract the subnet mask. Okay, from this the for all, and then you subtract from this /28. Okay, and then you will have this 0.0.15. Okay, all right, and then the ACE will be access list 10 permit 192.168.3.32.0. This is your wildcard. Okay, another example. Assume you needed an ACE in ACL to permit only networks. This network only and this network. 10 and also 11. Okay, these two networks could be summarized as, okay, they give this the subnetting. Okay, sorry, the subnet mask /23, which is a subnet mask is 225.224, and then subtract that from the subnet mask subtract this subnet from this 255. Okay, so this will produce 0.0.1255. Okay, the ACE will be access list 10 permit 192.168.0 that 10.0, yeah, 0.0 125 255. Okay, all right. This one for this scenario, right? Next, okay, wildcard mask keyword. Okay, the Cisco. So in Cisco iOS, yeah, provide two keywords. Yeah, two keywords to identify the most common use of wildcard masking. The two keywords are host and any. Host mean this keyword substitute for 0.0.0 mask. Okay, this must state that all IPv4 address bit must match to filter just one host address. Remember that this. So this keyword we use to replace the 0.0.0.0 mask. And also for this, in Cisco, we use any instead of 255, 255, 255, 255. Okay, this mask actually says to ignore the entire IPv4 address or to accept any addresses. Okay, so we can use host for replacing this or substitute to 0.0.0 mask, and also any for 255, 255.255.255. Okay, so we use this host and any. Okay, this one we will see this, okay, or we'll find this if we write ACL, okay, using when we write ACL, we'll use this somehow. In some cases, we need to use host and any. So at the beginning, just now we use 00 for specific. For specific machine. So similar, we can replace this host or substitute this with host. Okay, by default, host means 0.0.0.0 mask. Any means for here means 255.255.255.255. All right, these some keywords. Okay, you will find later, yeah, in the lecture or during we create an ACL. So guideline for ACL creations. Limited number of CL per interface. There is a limit on the number of ACL that can be applied on a router interface. Yeah. For example, a dual stack mean for IPv4 and also IPv6. Yeah. So router interface can have up to 4 ACL applied as shown in the figure here. Right. So specifically, a router interface can have one outbound for IPv4 and also one for inbound for IPv4 ACL. Similar for another IP address, one inbound and one outbound for IPv6. Okay, or from this example you can see. Okay, note ACL do not have to be configured in both directions. The number of CL and their direction apply to the interface will depend on the security policy of the organization. All right. KCL best practices. Okay. Using ACL require attention to detail and great care. Mistakes can be costly in terms of downtime, troubleshooting effort, and poor network service. So basic plan is required before configuring an ACL. So planning is very important. Similar when we do programs, so we need to plan properly. So you have to write down actually. Write down, and then you have to scratch. Okay, jot down what are the security, what are the entry ACL is, and so on. Similar to this case, okay, to avoid the downtime, troubleshooting effort, poor network service, So you need to have a proper plan. Yeah. Okay, guideline base ACL on the organization security policies. The benefit is to will ensure you implement organizational security guideline. Normally we do propose, okay, in the big organization you have to propose, not just simply, yeah, we create ACL, okay. So just this is just only a simple guideline only, yeah. Write out what you want to, what you want the ACL to do. Okay, you have to write out, do comment on that ACL. This will help you avoid and inadvertently creating a potential access problem. And then use text editor to create, yeah, edit and save all your ACL. This is very important. Yeah. Once you create, you have to save properly, keep that in the safe place. Okay. And then document the ACL. This is very important. So here we use word remark in Cisco. This will help you understand the purpose of and all the ACL or entries. Test the ACL on development network before implementing them on the production network. So this is similar way that we do. We have to do tests, yeah, before we go to the real network. Yeah. Okay, so means here they said this will help you avoid costly error. Okay, in a big company, this is very important. You have to take note as well. Yeah, all right. So type of IPv4 ACLs. So we have two kind of the ACL. One standard. Okay, the other one is extended ACL. Extended ACL means this permit or deny packet based on the source IPv4 address. So extended ACL, this permit or deny packet based on the source IPv4 address and destination IPv4 address, protocol type, source, and destination TCP or UDP ports, and many type of the applications. Okay, so this one just only two, so we got many actually. Yeah, all right. So numbered ACL. Okay, so this one is a guideline, guideline to, okay, the type of ACL. So the category based on that. So number ACL. So numbered and name ACL. So ACL number from 1 to 9, yeah, or 1,300 to 1,999 are standard ACL. Okay, while ACL numbered from this number 100 to 199, or from 2,000 to 2,699 are extended ACLs. Okay, so go to the router and then you type SS list question marks. So it will give all the details here. All right. So from 1 to 99, 100 to 199. So they will explain in here. Okay. Right. So number and the name. So name, so we can use a name. Okay. So name ACL are the preferred method to use when configuring ACL. Specifically, standard and extended ACL can be named to provide information about the purpose of the ACL. For example, naming an extended ACL FTP filter, for example, is far better than we just put a number. Okay, this one is similar that when we use a DNS, okay, we have a domain name and also the IP address. Okay, it's to better to use a domain name. So meaningful compared to this number, similar to this case. Yeah. So the IP access list global configuration command is used to create a name ACL. Yeah, as shown in the following example. All right. So this is one of the example regarding name ACL. Okay. So here, FTP filter. Okay, this is the example. And where to place ACL. Basically, every ACL should be placed where it has the greatest impact on the efficiencies. Okay, extended ACL should be located as close as possible to the source of the traffic to be filtered. Okay, standard and also extended. Standard ACL should be located as close to destination as possible. Yeah. Okay. Factor influencing ACL placement, the extent of organizational control. Okay, so placement of ACL can depend on whether or not the organization has control of both the source and destination network. And also is for bandwidth and also network involved. It may be desirable to filter unwanted traffic at the source to prevent transmission of bandwidth consuming traffic. So ease of configuration. It may be easier to implement an ACL at the destination, but traffic will use bandwidth unnecessarily. An extended ACL could be used on each router where the traffic originated. Yeah, this will save bandwidth by filtering the traffic at the source, but it will require creating extended ACL on multiple routers. Okay, standard ACL placement example. So in the figure here, the administrator wants to prevent originating in the IP from this network address, okay, /24 from reaching to this network IP .30.0/24 network. Okay. All right. So means block all traffic from 192.168.10.0, yeah, to 192.168.30.0. Okay, all right. So mean in this example, 10 from this side to this side. Okay, so following the basic placement guideline, the administrator will place a standard cell on router 3 in here. Yeah. There are two possible interfaces on R3 to apply the standard ACL. Okay, inbound and also outbound. Okay. So at S, okay, S0/1/1 is here. And then the standard ACL can be applied inbound, yeah, on the R3, yeah, S0/1/1 in here. Oh, sorry. Okay, and then however, it will also filter .10 traffic to the .31.0. Yeah, 31.0. Okay. Therefore, the standard ACL should not be applied to this interface. Okay. All right. So for the option R3, okay, with the R3 in here, G interface here /0, yeah. Interface outbound. Okay, the standard ACL can be applied outbound on R3. G0/0/0 interface. This will not affect other networks that are reachable by R3. Packet from .10, okay, this example .10, okay, from here .10 will be able to reach the .31 network here. Okay, this 31.10 here. Okay, this is the best interface to place the standard ACL to meet the traffic requirement. All right. Okay, so outbound in here, inbound in interface here. All right. So extended ACL should be located as close to the source as possible. Yeah. So extended ACL should be located as close to the source. However, the organization can only place ACL on devices that they control. Yeah, okay, correct. Therefore, the extended ACL placement must be determined in the context of where organizational control extends. Okay, so within their control, because they cannot go to beyond another organization, right? Okay, so that's mean by this scenario. In the figure, for example, company A wants to deny telnet and FTP traffic. Okay, this is a scenario, yeah, to company B. Okay, so company A wants to deny telnet and also FTP traffic to this company with this IP address network from their network 11.10, yeah, while permitting all other traffics. Okay. Okay, we want to block company A. So where is it? 3030 is here. Okay, we want to deny all the telnet and FTP to company B. Company A wants to deny. So company A wants to deny. This one, they need to do filter. Okay, deny telnet FTP traffic to this company. Okay, this scenario, for example, want to create that. Okay. So an extended ACL on R3 will accomplish the task, but the administrator does not control R3. Yeah, of course. In addition, this solution allows unwanted traffic to cross the entire network. Okay, only to block the destination. The solution is to place an extended ACL on R1. Okay, because R1 is belong to them. That specify both source and destination addresses. There are two possible interfaces on R1 to apply the extended ACL. Okay, so outbound, inbound. Outbound for this, yeah. Outbound and inbound for G001 in here. So for R1, the extended ACL can be applied outbound on the S0/1/0 S0/1/0 in here. Yeah. In here. Yeah. And then this solution will process all packet leaving R1, including from this IP. All right. And then next, the extended access can be applied inbound on G0/0/1 here. Yeah. And only packet from the 192.168.11.0/24. Okay, we'll filter from, yeah, examine traffic only from 11.11.11.0. Okay, all right. And only packet from this one .11.0 network are subject to ACL processing on R1 because the filter is to be limited to only those packets leaving 192.168.11.0 network. Applying the extended ACL G0/1 is the best solution. Okay, in here. All right. Okay, we done for this module 3. So let me pause this first. this, so this one is okay. All right, we continue on this, yeah. Module 5, yeah, ACL configuration for IPv4. Okay, in this module, I'm going to configure standard IPv4 ACL to filter traffic. And then we do some modification, use equal number to edit existing. And then configure standard ACL. And also configure extended IPv4 ACL to filter traffic according to networking requirement. All right. Okay, configure standard IPv4. Okay, creating an ACL. All access control lists must be planned, yeah, as I told you before. So we need to proper plan. When configuring a complex CL, it is suggested that you use text editor to write out the specific of the policy to be implemented. Yeah. And then add iOS configuration command to accomplish those tasks, including, so please include remark, okay, or something. Remark is every ACL. It's better to put remarks, okay. Easy for future if you do changes, everything, or we give a job to someone to take over. So there is a remark or documentation, so easy for them to do a troubleshoot, yeah, changes and so on. So copy and paste the command onto the device. Always thoroughly test an ACL to ensure that it is correct apply to the desired policy. Okay, number standard ACL. Okay, so to create a number standard ACL, use the SS dash or hyphen list. Yeah, so the syntax SS, this one hyphen list. Yeah, and then the number and what is the kind of the permission, and then IP address and your wildcard. Okay. So as I told you before, access this number between this range. Yeah, this range for standard ACL. Okay. And then this one, the access or specifier, what access specifier whatsoever. So we have deny, permit, or remark. Remark for command, for example. Yeah. And then we have source IP address here, and also this for wildcard mask. Okay. So with the no access list, yeah, access list. So no access list, and then access list number in global configuration is to remove the standard ACL. Okay. So if you type this no access list, and then the number of the access, no access list, and what kind of number, so it will delete. Yeah, delete the entries. Yeah. Okay. So here name standard IPv4 ACL syntax. To create name standard ACL, use the IP access list standard command. Yeah. ACL names are alphanumeric, case sensitive, and also must be unique. Capitalizing ACL names is not required but makes them stand out when viewing the running config output. Okay, for example, IP access list standard access list name. Okay, and then IP here standard access. So standard, and then what is the name of the ACL? What's the name? ACL you put no hyphen, okay, dash SS. Okay, and then if you type this in this, you type this, it will give the sequence number. They will set the default. We have a deny, permit, remarks. Okay, all this. Okay, apply a standard IPv4 ACL. After a standard IPv4 ACL is configured, it must be linked to an interface or feature. Yeah. So the IP access group command is used to bind a number or name standard IPv4 ACL on ACL to an interface. To remove, we use this no IP access, no yeah in the beginning, and this one the command IP access dash group. So interface configuration, add interface configuration command. All right. So the example ACL. Okay, for example, the example ACL permit traffic from host, this one, and to permit from this host and all hosts in this network. Okay, out interface serial S0/1/1 on router R1. Okay, we have a scenario in here. Okay, we want to permit traffic from this host and also all hosts under this IP address or network address. Okay, on serial interface 0/1/0 on router R1. Okay. So we create access list 10, the number, then put the remark just documentation, and we type entries ACA, okay, permits only host to the internet, for example. Okay. And then after that, access list. Okay, this is your ACL. Access list 10, label, number, permit, yeah, host. Okay, we use host, and this is the IP address, right? Yeah, IP address. And do show access list. So you can see this standard IP. So we'll give this 10, the label is 10, and then permit 192.168.10.10. Okay. All right. And then next, so access list 10, remark AC permit all hosts in LAN 2, for example. Okay. So this one for specific, this one for specific LAN, yeah, network address. So access list 10, permit 192.168.20.0, and then all hosts in LAN 2. So they say this is LAN 2, and then put the wildcard. Okay, 000.255. So /24. Yeah. Okay. And then if you do show access list, so you can see this one standard IP. So the next one, which is the next one is for second one will be appear, yeah, underlying of this, yeah, 10. You can see this, yeah. Okay, and then goes to interface, and R1 goes to interface serial 0.1.0, and then IP access group put in the outbound interface. So access group, okay, 10. 10 is here. Okay, all right. Next, use the show IP to verify. Okay, this one is similar to other command in Cisco. You need to verify that. Use the show running config. You have to review the ACL in the configuration. And also show IP interface. Command to verify ACL. Apply to the interface. Okay. Show run and then put pipe and section access list. So it will give you all this. Okay. Whatever you wrote for the ACLs, you can see here. And then show IP interface at serial, this at serial. And then include access list. So it will give with setting for outgoing and also for outgoing only. Not set all, not set. Okay. All right. Next. Okay, here the example ACL permit traffic from host, this host, and all hosts in this network IP, and then at serial interface on R1. Okay, so no access list. Then we remove that. Okay, and then we create IP. Just now we already create this one, right? So they will delete all this. Okay, look this one 10. So you remove this 10. So now IP access is standard permit access, and then remark, and then permit host. Okay. Okay, this one name extended. And then next for this. Okay. And then we remark host, and then remark all permit host in LAN 2. So permit 192.168.20.0.0.0.255. And then exit. And then we go to the interface, serial interface, and then setting. So this one using name extended example. Okay. So similar scenario. Okay, but two different kind of ACL. Standard. This one using name. Okay, name standard. And then how to check show access list and similar show IP interface. All right, this is the packet trace exercises. So how to modify? So in order to modify, so you can use text editor and also sequence number. Okay, after access configured, it may need to be modified. ACL with multiple AC can be conflict to configure. Okay, sometimes the configured AC does not yield the expected behavior. Okay, so text editor. ACL with multiple AC should be created in a text editor. This allows you to plan the required ACE. So create the ACL and then paste into the router interface. It also simplifies the task to edit and fix an ACL. To correct an error in ACL, copy the ACL from the running config and paste it to text editor. So any text editor. Okay. And then make the necessary edit or changes. And then remove the previous configure on the router and then paste. Okay, copy and paste the editor back to the router. Okay. All right, this is how you verify, show run, access list. You will give this. Yeah, all right. Okay, sequence number. Okay, NACL, ACE can be deleted or added using the ACL sequence number. Use the IP access list standard. Yeah, command to edit NACL statement cannot be overwritten using an existing SQL number. So how to do that? We cannot overreturn, so you have to delete the existing one. So you with this no 10, for example, in here, so it will delete this one. Okay, no 10, so it will delete here, and then you type again here. They'll type again. Okay, this one no 10, so you delete here, and then they will add. Okay. All right. Modify a name ACL. Okay, name ACL can also use a SQL number to delete and add ACE in example. And ACE is added to deny host 192.168.10.5. Okay, so you can do correction on that. All right, supposed to here. Okay, this one check first, and then we give here. So now we're going to modify. Go to config T IP access list standard no access, and then put 15 deny 10.5. Yeah, and then when you go out, and then we check show access list. So here 192.10.5, okay, is added, and also the other one 192.10.10 is already there. Okay, all right. ACL statistic. So the show access list command in the example shows show statistic for each statement that has been matched. So the deny ACE has been matched 20 times. Okay, and the permit ACE has been matched for 64 times. Note that the implied deny statement does not display any statistic. To track how many implicit deny packets have been matched, you must manually configure the deny any command. Use the clear access list counter command to clear the ACL statistics. So you can clear that. Okay, the history, all this using clear access list counters. Okay. Secure VTY port with standard IPv4 ACL. Okay, the standard ACL can secure remote administrator. So you can do remotely access to device using virtual terminal line by implementing the following two steps. Yeah, creating an ACL to identify which administrative host should be allowed remote access. Apply the ACL to incoming traffic on the virtual terminal lines. Yeah. Okay. So secure VTY access example. This example demonstrates how to configure an ACL to filter virtual terminal traffic. Okay, first local database entry for user admin and password class is configure. The VTY line on R1 are configured to use the local database for authentication, permit SSH traffic, and use the admin host ACL to restrict traffic. Okay, all right. And then, so verify the virtual terminal port is secured. After NSS to restrict access to the VT or virtual terminal line is configured, it is important to verify it worked as expected. To verify the access statistic, issue the command, issue the show access list command. The match in the permit line of the output is a result of successful SSH connection by host. This, and also the match in the deny statement is due to the failed attempt to create SSH connection from a device on other network. Okay. And then configure extended IPv4. Extended ACL provide a greater degree of control. Okay, they can filter on source address, destination address, protocol, IP. So, for example, IP, TCP, UDP, FTP, and also port number. So extended can be created as number extended ACL, also name extended ACL. Okay, for number extended ACL created using the access list or access list number at global configuration command. So created using the IP access list extended. So access list name. So number extended and also name extended ACL. Okay, protocol and ports. Extended ACL can filter on internet protocol and port. Use the question marks to get help when entering a complex ACE. The four highlighted protocol are the most popular option. Okay, all right. Okay, protocol and port. Selecting a protocol influence port option. Many TCP port available are available as shown in this output. Okay. So it's 100 permit TCP any yeah. Okay. Protocol and port number configuration. Extended ACL can filter on different port number and port name option. Yeah. Okay, this example configure an extended ACL 100 to filter HTTP traffic. And then the first ACE use the www port name. The second ACE use the port 80. Both ACE achieve exact the same result. Okay, so similar this, yeah. And then configuring the port number is required when there is not a specific protocol name listed, such as SSH use port 22 or HTTPS use port 443 as by default, yeah, as shown in the next example. Okay, all right, this one. Apply a number extended IPv for ACL. In this example, the ACL permit both HTTP and also HTTPS traffic from this IP network. Yeah, the IP network to go to any destination. Extended ACL can be applied in various locations. However, there are commonly applied close to the source. Here, ACL 110 is applied inbound on R2 for interface G0/0/0. Okay. Okay, this one different IP. Yeah, same different. All right. Okay, TCP establish extended ACL. TCP can also perform basic stateful firewall services using TCP establish keyword. Okay, so we have another keyword establish. Okay, by using this establish keyword, enable inside traffic to exit the inside private network and permit the returning reply traffic to enter the inside private network. Okay, so TCP traffic generated by an outside host and attempting to communicate with an inside host is denied. Okay, this one they use this keyword establish. Right. Okay, this is they're explaining the scenario. Okay, ACL 120, for example, is configured to only permit returning web traffic to the inside host. Okay, the ACL is then applied outbound on R1. Yeah, at this interface G0/0/0 interface. Okay, use the show access list command shows that inside hosts are accessing the secure web resources from the internet. A match occurs if the returning TCP segment has ACK or reset RST flag bit set indicating that packet belong to an existing connection. Okay, so this is the one. Okay. All right, access list, TCP, and then this interface, and then for outbound, and then show access list. So this one extend, yeah, IP access list. So 110 is a 120. Okay, and then naming and ACL make it easier to understand its function. To create a name extended ACL, use IP access list extended configuration command. In the example, the name extended ACL call no FTP access is created and the prompt changed to name extended ACL configuration mode. ACE statements are entered in the name extended ACL sub configuration mode. Okay, the topology below is used to demonstrate configuring and applying two name extended IPv4 on an interface. So surfing, this will permit inside HTTP and HTTPS traffic to exit to the internet. Okay, for surfing, and for browsing, this will only permit returning web traffic to the inside host, while other traffic exiting the R1 interface is implicitly denied. Okay, all right. So we have a surfing and also browsing. Okay, they allow certain accessing. One to access to the specific. So this one only one PC. So this PC can do surfing. Okay, and also the information. Okay, whatever content. So this one is browsing. So only this PC is allowed to access actually. Yeah. So name extended IPv4 ACL. So the surfing ACL permits HTTP and HTTPS traffic from inside user to exit the interface G0/0/1. Yeah, and then okay, web traffic. Yeah, web traffic returning from the internet is permitted back to the inside private network by browsing ACL. Okay. So request fine or surfing and then browsing returning. If ACL extended surfing, okay, this one. Okay, and exit. So SSD extended browsing. So remarks only returning, only permit returning HTTP, HTTP traffic. Okay, permit TCP any. Okay, 192.168.10. Okay, establish. This is called establish. Yeah. So then exit interface G0. Then IP access group. So surfing in. So inbound. So this one for browsing for out. Okay, inbound. Okay, surfing in here. Okay, inside. So browsing and they receive outbound. Okay. And then the surfing ACL is applied inbound and the browser ACL is applied outbound on R1. Okay, so if you check back, show access list, so it will give you this, yeah, information 10 or 20 here, we can see. So this is a number. Okay, so they will give you how many analyzing, how many times. Yeah, so this one we have 124 matches compared to this, yeah, 369 matches. Okay, this one regarding surfing, also browsing. So we allow one PC to browse, surfing, and then get the data. Okay, get the response, get the result from the server. Okay, all right. So this is the access list, the example of access list. Yeah. All right. To show access list command is used to verify the ACL statistic. Notice that the permit secure HTTPS counter, which is this, yeah, 443 in the surfing ACL, and the return established counter in the browser ACL have increased. Okay. Okay, we can clear as well this, and then we can check back. Yeah. Okay, an extended ACL can be edited using text editor when many changes are required. Or if the edit apply to one or more entries, then sequence number can be used. Okay, the AC sequence number 10 in the surfing ACL has incorrect source IP network address. Okay, number 10. Okay, this one source IP. Okay, so the AC sequence number 10. Okay, in the surfing ACL. Okay, surfing ACL. This one. Okay. Okay, here. Yeah, 10 permit. Number 10 in the survey has incorrect source IP address in here. Okay, source IP. This one 19. Yeah. All right. So to correct this error, the original statement is removed. Okay, as usual, we need to remove by with the command no. Yeah, no. And then command and the corrected statement is added, replacing the original statement. Okay, and then the show SSD command output verify the configuration change. Yeah. Okay, so IPSS we just type no. Yeah, no 10, and then we type again 10 permit 192.168. We do correction, so we put new entries and then finish and show access list. So you see here, so they do a correction. All right. And then another extended IPv4, okay, ACL. So two name extended ACL will be created. Okay, we have one more scenario. Permit PC1 and then reply PC1. Permit PC1, this will only permit PC1, get TCP access to the internet and deny all other hosts in the private network. Okay. And then second one, this will only permit specific returning TCP traffic to PC1. Implicitly deny all other traffic. Okay, clear? All right. So in here. So this is a PC. Okay. So another extended. Okay, the permit ACL. Okay, permit this TCP access to this FTP, SSH, Telnet, HTTP, and also HTTPS traffic. For example, this. So permit TCP host port 20, port 21, 22, 23, 53, 80, and also 4443 for HTTPS. So we include all. Yeah. So and then the reply PC1 will permit return traffic to PC1. Okay. Right. So the permit, 1 second. Permit PC1. Okay, the permit PC1 is applied inbound and the reply PC1 ACL apply at outbound R1. Okay. So this one for permit and then this one for reply. Okay, only returning traffic to PC1. So permit TCP, any host, yeah, and then we put establish. Okay, so accept this and then we exit and come back to the interface and put permit PC1 in for inbound, reply PC1 is for outbound. So we apply the ACL. Okay, so verify similar, we use show IP interface. Okay, we do similar using the previous example. And then show access list command can be used to confirm. This one same from the previous one. So we want to double check that. The setting, okay, the access list. Yeah. Oh, what is this? Show access list. And this one show running config. Okay, and then we put here pipe begin IP access list. IP access extended permit PC1. Yeah, remark permit PC1 TCP access to the internet. So all this, and then IP SSL standard reply. Remark only permit return traffic to PC1. Permit TCP any host, yeah. And then okay, this is your exercises. It will be created later. Okay. Okay, that's all actually for lecture on configuring ACL. Yeah.